Hello. Some time ago I have recorded a video on vectorizing Pandas code, and it was quite popular, and people asked me like, okay, please show an example of how you do vectorization of your code to speed it up, and in this video I will show it to you. If you don't know about what is vectorization and how Pandas can be fast, review the previous video. I will put a link in the description for that. And yeah, let's start. So I have a project that I prepared for this demo, and basically this project is a Python one, and it contains a function that I want to vectorize. The function does the following thing. It takes a data frame as an input and outputs the data frame. Inside the code, it does some transformation, and this transformation partially is not vectorized. And you may notice that here I use not just PD data frame, but specific types, and it's done with the help of pandera schemas. You can see schemas here, and yeah, this means that I know what data is expected as an input and output, and the code is automatically checking for that. So I have a video about pandera schemas. I will also put it in the description, so if you want to get familiar with that, check it out. So input data frame is like this one. It's time series data about the market price of some asset. It contains unique integer index, open time, timestamp, open, close, low, and high values for the price. And output contains the value of CCI indicator. That doesn't matter what CCI actually means. It's some statistic calculated based on price. And if the data is big, it will take some time to calculate it, and vectorized form that will be much more faster than non-vectorized one. So it's timestamp and CCI value for a given timestamp. Let's see what the code does. So it does some timestamp transformation first, so it's fast, like no heaviness here. Sets some index, calculates number of expected rows. Then again calculates like typical price, calculates moving average. These parts are already quick, so all these operations are vectorized. Then drops non-numbers, also fast. And here we have a heavy operation. So what this piece does is that it takes low values, the series of row values, then applies window to that, and then does pandas apply. And pandas apply will run this function on each sequential piece of information. So if data frame is like of 1,000 rows and I have a window of 5, then this window of 5 will move through the data frame almost 1,000 times, and the function will be called almost 1,000 times. If the data is like 1 million long, then it will be called 1 million times, which will be slow. And then we have this again drop an A, fill forward, which is quick, and then yeah, convert into data frame, adjusting index and returning. So this piece is slow, and let's see what it contains inside. In this piece we get basically the full data frame as an argument and the particular slice that we want to calculate indicator on. And here we calculate some absolute deviation inside the window. We basically select the window here, the rows representing corresponding to the window. Then we calculate mean value inside the window. Then we select last values in there, and then we calculate the actual CCI value here with some if. So if we do this just once, it will be fast, but if we do this million times, it will be quite long. It will take much time. And this code can be vectorized because basically we don't have any non-vectorizable operations here. So let me show you how it's done. First thing that I do, and I recommend you to do that, is I will create a test that will save the outputs of the current function so that I will be able to check the vectorized one for correctness. So I will create a test here. So in the test, I will import the vectorized, the CCI calculation. Okay, so I'll define the test. Now I need some input data, and I have input data prepared. So it contains some open time, open, close, high, low values for some timestamps with a step of 15 minutes. So I will use this one. Okay, so the data is located relative to the test, so I will use it. Okay. Yeah, then I would need to transform the values, because you see that I have timestamps here, and by default they will be read as strings, and these are integers, and the schema requires me to have datetime here and float 64 here, so I will do that. Now we'll transform the, no, I need to do that. Yeah. And it will be explicit probably like that. 64. Okay. What next? I want to calculate the CCI, and I will use, let me see, what will I use? Yeah, I will use period of 3, let's say, steps, and time frame will be 15 minutes. It doesn't matter actually for the sake of vectorization what I will select. And yeah, let's see if this test passes now. It's not finished yet, but I saw it. Okay. Oh, I need pass. I need file here. So it's the path to the current file to the file with the test. Okay. Something still wrong. Okay, so it's okay. It's also a file, and now I need to read CSV like that. Okay, so CSI is calculated, and what I do next is I save the results to a separate file, so that I will be able to read the results and compare them with what vectorized version will generate. And in order to do that, I will modify it a bit. Okay, and I will save CCI to CSV now. And as far as I remember, it contains, yeah, timestamp in the index, so I do want to save the index. And then I want to read the CCI. And yeah, again, it's CSV. I use CSV just for the sake of demo, so that you will be able to see the data. But in reality, I could use Parquet, and in this case I won't need to do these conversions, because Parquet will save all the types in the way I want them to be. But in this case, timestamp will be saved as string, so I need to convert it back, and timestamp won't be saved as index, so I would need to set it as index. Yeah, like that. And yeah, let's see if it works now. Okay, so it's saved, and I see CCI data appeared here. And what I do next is I command this piece where I save CCI. Oh, but I still calculate CCI. I calculate actual CCI and do check that actual is equal to expected. Let me see. Okay, so it's correct. So now if I change this function to another one, I would check the result versus what I know is correct. So let's move forward. What I do next is I go to this CCI file and rename this function. I will call it CCI, calculate CCI alt. And then I copy its entire code, right? And if I define calculate CCI, now I command this piece where I apply non-vectorized code. In your case, it may be some apply or some other thing, but you isolate this piece of code, right? You know what you need to isolate. And probably also this one will be somehow refactored. And I know that the implementation is here, right? So that's what I want to have here. So I put it here. And let me see what I need to do with this code. So first, I don't need to select window, I do need to calculate the absolute deviation, and absolute deviation can be calculated inside the OHLC. So, and what I need to do, I need to take the price minus over mean average, right? So mean average is calculated already, right? So I have done what? I have done this piece of calculating absolute deviation. Let's see what's next. So this one is calculated, and this one is also calculated, or not? Let me see. No, not yet calculated. Yeah, what I do next is, so in this case, this absolute deviation was calculated for this piece, right? So window OHLC is just a piece of data, the one that is selected by the window, and mean is calculated for this window, which means that I need to do rolling operation in order to get the same result. So I'll do that. So I'll get back here and I type. MAD in this case means mean absolute deviation, and yeah, I do rolling operation with this period, with this mean periods, and yeah, it should be not centered, and then I calculate mean, right? So I take this, calculate rolling with this period, and calculate mean. Okay, super. So I've done this thing now. And yeah, be careful in case you do this for a rolling thing. Check like what should be done with the entire data frame and what should be done in the selected chunk, by this chunk selected by the rolling thing. Okay, then here in TP and MA, I'm selecting the last value in the window, but in my case I can calculate it for entire data frame for each row, right? And next, what I do is I calculate the CCI already. And I calculate it with this formula, right? So it should be typical price minus moving average, right? Here, these things divided by this multiplier multiplied by window MAD, right? So it's here. Okay. And I do round. So now I can just use not this round, but series operation for round. Again, this is here, this is here, this is here, and this is here, right? And I do round here. So CCI is calculated. And yeah, then I have this piece of setting zero value in case mean absolute deviation is 0. And it's needed because I divided by AD here. So what I do next is I need to do this thing. So where MAD is equal to 0, CCI should be set to 0. Yeah, seems correct. So Copilot helps me to do that. Great. Okay. And yeah, what's next? Okay, yeah, I probably missed something here. Let me see what I deleted. So it's converting to frame, but I need to check for non-values also. Yeah, let me get back. So I've calculated CCI now, but yeah, there was some check afterwards after the rolling operation. Let me see. So yeah, so I calculated CCI here. Yeah, I need to do this. CCI series. Okay, I'll do that. So in CCI series is what? CCI series is OHLC CCI. Okay, so use CCI, forward fill, and convert to frame. Yeah, seems more or less correct. So this piece was in the previous function. This piece was overwritten, right, in vectorized form, and I don't have any apply here now. And yeah, drop this one. So I have the test, so that's why I'm quite safe that I will check if the result is correct. Let me see. And I get back to the test and see here I just use calculate CCI function, which is a vectorized form now, right? The one that I implemented. So let's see if it will pass the test. Oh, click the back. Okay. Yeah, it failed. What's wrong? Yeah, it's different a bit. but generally correct. I believe it's just because I saved the rounded value and I haven't rounded values here. Let me see. Oh yeah, I'm rounding only the denominator but not the entire result. That's what happened here. Okay, so checking again. Yeah, and now the test has passed. See? And what I do next is I drop this non-vectorized form. It will still remain in the repository. So I drop this one. So the history will have it just in case. I drop this one. I don't need this function that was under apply anymore. And yeah, that's it. So I've made the vectorization of the function. Initially it was using apply, and now it doesn't use any apply, and on big data set it will be about 100 times, probably even 1,000 times faster. So it's great. And if you like this example, please press like and subscribe to my channel, and see you soon.